Okay, so again, my name is Yair, and today I'm going to show you how I managed to turn EDRs and antiviruses into malicious wipers using zero-day vulnerabilities. So, as mentioned, this is me. I'm the security research team lead at SafeBreach. I have more than 6 years of experience in security research. In my past, I did some Linux, embedded, and Android research. And for more than 3 years now, my main focus lies in Windows research. But let's see what we're going to talk about today. So, we'll start with presenting the research goal that I defined when I started the research. We'll then get some background about wipers in general, understand what they are, how they work, and what they are used for. We'll then deep dive into the research process itself to see how it found the zero-day vulnerabilities that enabled the creation of Aikido wiper. So let's begin. When I started the research, I wanted to create some sort of a next-generation wiper, a wiper that will be different than all other wipers that we know today, and that will provide some extra value. But in order to create the next generation of anything, one must first understand the current generation, of course. So, what is a wiper? According to Wikipedia, a wiper is a device used to remove rain, snow, ice, washer fluid, water, or even debris from a vehicle's front window. But of course, this is not the wiper that we're going to talk about today. And instead, we're going to talk about the wiper malware. And after fixing the search in Wikipedia, you'll find that, probably like most of you already know, a wiper in computer security is a class of malware intended to erase the hard drive of the computer it infects, maliciously deleting data and programs. And why are wipers even used? So, as opposed to most malwares that we know, which some are used, of course, to collect intelligence, some used to collect ransom, this type of malware is not used to collect anything. Instead, its main focus is just to damage its target entity. It doesn't matter if this entity is a certain state, company, organizations, and so on. The target is really to damage the target entity, and we also have some examples here in which we can see that Russia was attacked by wipers, or Ukraine was attacked by wipers, same for Israel and Iran, and basically everything that we hear on the news about rivalry between countries is also expressed in cyber warfare, of course. But we are not here to talk about rivalry between countries, but rather about technicalities of wipers, and specifically the next generation wiper that I created. So let's start getting some technical background about wipers in general. And in order to really understand how wipers work, we must first understand the crucial difference between deleting and wiping. That is because deleting is something that is very much associated with wiping, but they are actually not the same thing at all. So let's take a look at the deletion process in Windows in order to understand exactly what the deletion is. When a certain process in Windows calls the delete file API function, of course, a few functions happen later as well, but eventually it reaches the kernel, and then the kernel goes to a certain place that is called the MFT on the hard drive. And MFT stands for the master file table in the NTFS file system. And in this table, it just marks a certain entry as free. Now, this entry is just the pointer to the actual file content. So by deleting a file, we're not actually deleting its content, but just the pointer to it. And that is the exact difference between deleting and wiping. When we say that we want to wipe something, it means that we want to completely erase the content itself of the file in order to make it impossible to restore. However, a deletion can be escalated to a wipe. That is because when MFT entries are freed, they may be reused again, of course, because otherwise we'll just be running out of disk space in no time. So when we create a new file, our new file is potentially given an MFT entry which was marked as free. And then when we write some new content to this file, we're basically overriding content from a deleted file that is still left on the hard drive. But when I approach to see how wipers nowadays work, I actually saw that most of them do not delete files, and instead they straight ahead go and overwrite them. By overriding the content of the file, they can make sure that they are actually erasing the content itself because they are replacing it physically on the hard drive. Now, if a wiper wants to do that and really make the system impossible to boot and also wipe files that belong to an administrator, then it will, of course, require administrator privileges. And this technique is also used by very famous wipers that we all know. Another technique that is very popular among wipers is called the drive destruction technique. In this technique, the wiper basically opens the hard drive as a device, and it just starts writing random bytes directly to it. By writing random bytes to the hard drive as a device, the wiper can overwrite structures that belong to the boot operation, it can overwrite structures that belong to the NTFS file system, and it can overwrite files themselves. This operation, of course, also requires administrator privileges, as it's an operation that can completely ruin the computer. And again, like the previous technique, it is used by very famous wipers that we all know. However, after studying about these wiping techniques, or any other wiping technique, I had a crucial insight. The insight was that each and every one of the techniques were obviously initiated by the process of the wiper itself. So that means that basically if we'll open process monitor, for example, while a wiper is running, then we will see a process, the process of the wiper, running and opening and writing to a lot of files, which is extremely incriminating. But what if the next generation wiper that we'll create will be able to wipe all of those files without calling these very obvious and incriminating API calls? And what if this very same next generation wiper will also be able to do all that as an unprivileged user? Looking at this goal, I thought about Aikido. So Aikido is a martial art that specializes in using the power of opponents against them. But how is a martial art related to a wiper research? So basically, the #1 opponent of wipers is EDRs. Why? Because they have a very special superpower. They have the superpower to delete almost any file on the system, no matter the required privileges, as they run with the highest possible privileges because they have to do a lot of things on the computer, of course. But before we are going to understand exactly how we can Aikido EDRs into deleting our target files as an unprivileged user, we must first understand when do EDRs even choose to delete or quarantine files. So, of course, it depends on the configuration. But the most default configuration that I saw is that most EDRs choose to automatically delete or quarantine files that are detected as surely malicious. Some of them detect these files when the files are open, some when the files are closed after they were written to, and in addition, most EDRs suggest an option for a general system scan or just a scan of a custom path. And now that we understand when they actually choose to delete or quarantine files, we must understand another thing, and that is that looking at this research, step 1 is already accomplished. That is because of the nature of how EDRs and antiviruses delete files, we already have the ability to trigger a deletion. As unprivileged users, we can create a malicious file which will trigger a deletion by the EDR. All that we are left with to do is to trigger this very same deletion for the wrong file. So once you think about it like this, the first idea that comes to mind is maybe to just add some malicious content to an innocent file and then wait for the EDR to delete it. However, if we'll want to delete files that belong to an administrator or system files to make the system unbootable, then we'll again need administrator privileges. And from an API point of view, this will also very much look like the file override technique, because it will be the same API calls. And then the second idea that you can have is to maybe somehow point the EDR or the antivirus towards a different path while it still thinks that it deletes the original path. And a very good lead to do such a thing would be with links. Now, the link vulnerability category, CWE59, is already very well known to us researchers. There are so many link vulnerabilities in the past that Microsoft even know that they must have the create symbolic links user right that is given only to administrators by default. However, we have three types of links in the NTFS file system. We have symbolic links, we have junctions, and we have hard links. Now, internally, junctions and local directory symlinks do not work the same, but from a high-level point of view, they work exactly the same. A junction functions just like a local directory symlink. However, a junction does not require any special permissions to create it. So, and it doesn't matter also the target of the junction. So basically at this point, I understood, of course, that I should probably use junctions for this purpose. But even knowing that I'm going to use junctions, I still needed to find the right window of opportunity, of course. And in order to do that, I had to understand that there are two crucial events in the process of file deletion by the EDR. The first event is the time in which the malicious file that was just detected is being detected. Once the EDR understands that this file is malicious and it wants to delete it. The second event is the time in which the EDR really decides, really deletes the file itself. So we have, again, the time of detection and the time of deletion. Between these two events, there is a potential gap that I will maybe be able to exploit in order to redirect the EDR or the antivirus towards a different path to delete. Again, after the EDR already decided that it wants to delete the file. Now, let's take a look at an example of what was my initial idea for doing that using junctions. So on the left side of this slide, we can see the location of the very crucial driver in Windows that is called ndis.sys, which is located in the default drivers directory in Windows, in C, Windows System32 drivers. Now, let's say that we want to delete this driver as an unprivileged user. What we can do is to create a path which is very, very similar to the path that we want to delete, but it is located inside a directory which is under our control as unprivileged users. So we are creating, on the right side of the slide you can see it, we are creating temp Windows System32 drivers ndis.sys again. But into ndis.sys, we write malicious content that the EDR or the antivirus wants to delete. Then, if right before the deletion occurs, we delete everything from inside the temp directory that is under our control and convert the temp directory to be a junction that points towards the C drive, then as a result, the same path that used to lead to the malicious file that we created now leads to the legitimate critical driver ndis.sys. So with this idea, I started testing it. I tried to create mimikatz in the path, again, ctemp Windows, system32 drivers, and this.sys, as an unprivileged user, of course. And then, using the proper tools, after I created the file, just before it got deleted, I tried to delete ctemp and create ctemp as a junction towards the C drive in order to redirect the deletion. However, these attempts failed. I witnessed two primary behaviors by EDRs and antiviruses. The first one was that some of the products just had a very good grip on the file right after I created it. So basically, no matter what I did, no matter which tools I used, I could not prevent EDR from deleting the file, and I didn't have the chance to delete everything from the temp directory and create a junction instead. And the second behavior was that some EDRs, just after the file got deleted, they understood that the threat does not longer exist, and there is no need in deleting a file. So at this point, I understood that the potential gap that I imagined does not really exist. And so I had to expand or create it somehow. What I used is a technique that is called handle catching. So most of you probably know the create file API function in Windows, which helps us get handles for files that we want to create or open. And one of the arguments for this call is called the file sharing mode. The file sharing mode specifies whether other processes should be able to read, write, or delete the file that we are currently opening or creating. What I did was to set the file sharing mode for the malicious file that I'm creating to be read-only. As a result, other processes, among them the EDRs and the antiviruses, were able to detect that the file is malicious, but not to delete it. Then what happened next is that these products started to bring up messages that tell me that I should reboot my computer in order to fully get rid of the threat. So let's see how they implemented it. The first group of products basically used a built-in API in Windows for postponing a file deletion to after the next reboot. An example for such an EDR is Sentinel-1 XDR. The second group of products basically just implemented this functionality on their own, so they just kept a list of files to delete after the reboot somewhere, and then after the reboot, they actually deleted them. Now, looking at the built-in API in Windows for postponing a file deletion, it is done using the function moveFileEx with a special flag that is called moveFile delay until reboot. You can only use this flag if you're an administrator, and that is because once this function is called with this flag, then it goes to a certain registry value that is called pending file rename operations. To this registry value, it just adds an entry, which is the path to delete after the reboot. However, the pending file rename operations feature blindly follows junctions. And apparently, some self-implementations of other products do that as well. So overall, this meant that I could combine out of the two techniques that I used with the junctions to redirect the deletion and the handle catching, I could combine them both in order to create one complete process that allowed me to delete almost any file that I wanted on the system as an unprivileged user. So if we'll take the undetectable file example again, in order to execute the exploit properly, what we'll need to do is to create it under a directory which is under our control as unprivileged users. In this example, it's ctemp. So we're creating ctemp Windows system32 drivers, then undetectable with malicious content inside that the EDR wants to delete. Then we keep the handle to it open after we mentioned a read-only file sharing mode once we created the file. And by doing that, we're forcing the EDR or the antivirus to give up on the deletion and postpone it to after the next reboot. Once the product postponed the deletion, it is safe to close the handle, delete the ctemp directory, create the ctemp junction instead, point it, of course, towards the C drive. Now the same path that used to lead to our malicious file leads to the real driver. We are rebooting the computer, and then after the reboot, the index.sys file will be deleted by the EDR or antivirus product. So by doing that, we accomplish the two what-ifs that we defined in the beginning of the talk, and I promise you that any other edge cases will be answered in the rest of the talk. So let's first start with the zero-day vulnerabilities that I found as part of this research. So 6 products were found to be vulnerable against these vulnerabilities. It's Microsoft Defender, Defender for Endpoint, Sentinel-1 XDR, Trend Micro Apex 1, Avast Antivirus, and AVG Antivirus. Overall, 3 CVEs were granted. That is because apparently the vulnerability is in the same code for Defender and Defender for Endpoint. Unfortunately, Sentinel-1 did fix the issue but did not issue a CVE. Trend Micro, yeah, 1 CVE is expected. And I was also surprised to learn, but it's good to know, that Avast and AVG belong to the same vendor called Gen, and they use also the same source code that is vulnerable to this vulnerability. I also have one more disclaimer, and that is regarding the vulnerabilities in Defender, and they allowed me to delete only whichever directory that I wanted and not any file. But as a wiper, this really doesn't matter too much, as you just want to delete files. So if you want to delete a certain file, you can just delete its parent directory, and it will be deleted. Now we have our first demo for this talk, in which we'll see the pure exploitation against the Defender products, not yet with the Aikido wiper in action, but just the pure exploitation, trying to delete the entire drivers directory in Windows. So let's take a look. So now we'll see the drivers directory. We'll see that it has dozens of drivers. Now we see that we are running as a user called limited, and limited belongs to the normal unprivileged users group. Now we're creating a temp directory and placing Windows System 32 inside, and then we're creating a file called drivers, just like the drivers directory, which has malicious content that EDR wants to delete, and we keep the handle to it open with a read-only file sharing mode. Now we ask Defender to scan this path just to rush the process. Defender tries to delete this file. It can't. So it gives up on the deletion and asks for a reboot. Now it is safe to close the handle to this file, delete the temp directory, and instead create a junction towards the C drive. Now we'll reboot the computer, and let's see what happens. So the reboot happened. Now we have a small bug in Explorer. But if we'll see the drivers directory again, then we'll see that most drivers were deleted. Basically, Defender iterated through all drivers in the driver directory until it encountered one that is probably running, and it could not delete. But basically, it deleted almost all drivers in the drivers directory. And of course, after the next reboot, the computer is not able to boot anymore. Thank you. So this exploit is also effective in order to bypass a ransomware protection feature in Windows that is called the controlled folder access feature. Basically, this feature prevents untrusted processes from modifying or doing any changes, deleting, creating any file that is located in one of the protected folders that this feature defines. You can also modify this list. But basically, this feature is not going to prevent the most trusted entity on the system, which is the EDR or the antivirus, from deleting a file that is considered to be malicious. So it is also relevant to bypass this feature. Overall, I tested 11 different products, and more than 50% of these products were vulnerable to this type of an exploit. And the products that were not found to be vulnerable, I actually just was not able to force them into postponing the file deletion to after the next reboot. So if you try to do that, and if you find a way, there are very good chances that they will be found to be vulnerable against such an exploit as well. So I really encourage you to try and do that before real attackers do. And now to the actual Aikido wiper tool. So I implemented it with the exploits against the Sentinel-1 XDR, Defender, and Defender for Endpoint, just because they were the easiest to implement and most consistent with the exploit. The wiper is able to make the system completely unbootable. As we saw, it can delete system files, and it can delete almost all the drivers in Windows. It is fully undetectable, as it deletes files using the most trusted entity on the system, again, which is the EDR or the antivirus. And in order to minimize the noise from the creation of a malicious file, the wiper uses the ACAR test file, which is a file that EDRs and antiviruses are obligated to delete. So it's not a real malicious file that is being created. It is running, as we mentioned, with the privileges of an unprivileged user, and it's still able to do all these deletions. It is able to wipe important data that belongs to an administrator, and it can even delete an entire admin user directory, again, running as an unprivileged user, and we'll soon see a demo of that. Now, I'm sure that many of you, if you remember in the beginning of the talk, I mentioned that there is a crucial difference between deleting and wiping. So I'm sure that many of you thought about the fact that, like, wait, we can delete files, but we want to wipe them. So we need still to deal with this gap, and I dealt with it, and it was actually pretty easy. All that I needed to do is that after the reboot, I needed to just create a very big file with a lot of random bytes, which basically just overwrites the left content from deleted files that is left on the hard drive. I also verified with 2 popular file recovery tools that they were able to recover some of the files before I implemented this feature, but after its implementation, they were not able to recover any of the files. And another edge case is what happens if the EDR or the antivirus is configured to quarantine files and not to delete them. Basically, dealing with this feature was actually pretty easy too and a little bit funny. So what I needed to do is just to mark, using the exploit, I just needed to mark the quarantine directory for deletion as well. And then what happened is that the product tried to quarantine the quarantine directory, and the result was that it deleted the quarantine directory. So we bypassed this edge case as well. The repo of the code is very well documented, and I tried to implement some good design for it, so it will be expandable. So you really have my invitation to deep dive into the repo, scan the QR code. It is live on GitHub. So again, I encourage you to find more of these Aikido vulnerabilities. I'll give you another moment to take a picture. You can also just search Aikido wiper on Google. So now we have our second demo for this talk. In this demo, we'll see the actual Aikido wiper in action in an attempt to run as an unprivileged user and delete an entire admin directory with all of its content inside, and also deleting the quarantine directory. against the Sentinel-1 XDR product. So now we're logged in as an administrator. We see that the administrator has a lot of files in its user folders. Let's see that this is really an administrator. It belongs to the privileged administrators group. Now we're switching to the limited user again. We'll just again see that it is indeed unprivileged. So we see that it's in the unprivileged users group. Now we will run the wiper with the mode proxy deletion in order to attempt all user data of the user admin. Now we see that the admin directory exists in the users folder. We run the wiper. It exploits the right vulnerability, the right exploits for the right EDR. It does it for the quarantine directory as well. It reboots the computer. And then let's see what happened. So after the reboot, the admin directory is fully gone. It was deleted by the unprivileged user. Thank you. And we can also see that the disk is starting to fill up with random bytes because the wiper was run silently after the reboot to fill the gap between deleting and wiping. OK, so let's summarize everything that we can learn from this research. The first takeaway that we have is that, of course, a wiper or any other malware is by far more dangerous if it uses a trusted entity on the system, and especially, like in our case, the security control. Second, this is very important to understand. Having security controls does not mean that you are actually secure, so keep that in mind every day and keep validating yourself. Third, security controls might be a very preferred target for an attacker as they have very high privileges and they are extremely trusted. Lastly, and this is pretty obvious, always assume that permissions can be escalated, of course. Now, I do have some vendor responses in here. Overall, I have no complaints. They were pretty cooperative. They all fixed the issues. I won't read them to you, but you can take a look at the slides later. So we have Microsoft's response. They were very cooperative. This is true for Gen as well. These are the versions that you want to make sure you're updated to in order to be safe from these Aikido vulnerabilities. And lastly, I want to finish with something that still exists today and is really important in my opinion. So basically, any occurrence, this is very important to understand, any occurrence of the pending file rename operation feature that is being used against a path that can be controlled by an unprivileged user. So let's say someone uses the pending file rename operation feature to postpone a deletion for a file that is present in an unprivileged user directory. What happens is that the vulnerability is immediately created, and this is not very intuitive to understand. That is because the unprivileged user can delete one of the upper directories of the file that is targeted for deletion by this feature and create the junction and point it towards somewhere else instead. So this is still a risk that in a certain level exists. I want to thank Shmuel Cohen, which is a security researcher in SafeBreach, for helping me. Thank you for helping me testing the exploits against different EDR and antiviruses products. And pretty much this is it. I hope you enjoyed.